You've got the perfect cast. The bass follows, starts to suck in your bait, and immediately turns tail. What if the real reason wasn't your lure's action or color, but something most anglers completely overlook? The bass's sense of taste. I'm Travis from Green Valley Anglers. With 30 years chasing these green fish from muddy farm ponds to crystal clear highland reservoirs, I've dedicated my life to learning everything I can about bass fishing. And what I have learned is that taste can be the final gatekeeper that decides whether a bass swallows or rejects your bait. So today, we're diving into 3 key scientific studies on bass taste. Linser's 1998 work on pharyngeal taste buds and teeth, Ogawa and Caprio's 1999 Citrate Enhancement research, and the brand new 2025 loose study on taste bud development in largemouth bass. You'll discover exactly how bass taste works, what flavors they love or hate, and the simple tweaks that turn short strikes into solid hook sets. Stick with me. This knowledge has saved more fish for me than any new rod ever could. How bass taste works, the extraoral and oral systems. Bass have an incredibly sophisticated sense of taste that goes way beyond what most anglers realize. Unlike us, where we taste is mostly on the tongue, bass have taste buds distributed throughout the mouth, on the lips, inside the gills, and even in the pharyngeal jaws, which are the crushers at the back of the mouth. This creates 2 distinct systems, an extraoral taste on the outside of the mouth and lips for initial investigation, and oral taste inside the mouth and pharynx for the final swallow or spit decision. Each taste bud contains receptor cells that detect specific chemicals, primarily amino acids, the building blocks of proteins in their natural prey like crawfish, shad, bluegill, and everything else on their menu basically. Bass are carnivores, so their taste system is highly tuned to proteins and certain organic compounds, not sweets or carbs. I remember my early days in farm ponds, throwing basic plastics and wondering why bass would follow but never commit. One day, I started dipping baits in garlic scent, and suddenly those short strikes turned into solid hook sets. That was my first real clue. Taste is what seals the deal after the initial strike. We all want more committed bites and fewer lost fish. So if you miss the taste factor, you're leaving fish on the table. Those followers that look at your lure but reject it at the last second. But if you get it right, and suddenly your hookup ratio skyrockets because you're speaking the bass's chemical language. So bass have taste buds everywhere. But what happens once the bait is inside the mouth? Linser's 1998 study gives us the answer. Pharyngeal taste buds and teeth, the final gatekeeper. Dr. Peter Linser and his team at the University of Florida used scanning electron microscopy and histology on largemouth bass to map taste buds in the pharyngeal jaws, the grinding teeth or crushers in the back of the throat. They discovered a high density of taste buds clustered right around those teeth, creating a final taste checkpoint before swallowing. The study showed that once a prey item reaches those crushers, the bass uses this localized taste and teeth system to evaluate it one last time. If the chemical signature matches natural food, high in preferred amino acids, the fish will swallow. If not, spits it out instantly. This explains why bass sometimes mouth a lure briefly and then reject it. Taste is the final veto. In clear lab conditions, they confirm taste buds here are highly sensitive to amino acid profiles from real prey. My breakthrough came years ago on Lake Berryessa. Loved throwing a jig at that place, but it totally felt like it was getting nipped at. Picked up, dropped, and when I reeled down to swing, nothing was there. I decided to dip it in pure crawfish scent, rich in arginine and lysine. The short strikes disappeared, and I was hooking up solid. That study finally explained why. Linser showed us the final checkpoint. But what specific flavors turn a maybe into a yes? Ogawa and Caprio's 1999 electrophysiological study nails it. Citrate enhancement of amino acids, the final flavor booster. Dr. Ogawa and Caprio at Louisiana State University recorded electrical activity from what is called the glossopharyngeal nerve, which means the main taste nerve in the mouth of the largemouth bass. They found the bass taste system is highly selective to basic amino acids like arginine and lysine, common in natural prey, but almost unresponsive to plain citrate. The game changer, when they added citrate ions, the same ones in many natural prey tissues, to those amino acids, the taste response jumped dramatically, sometimes doubling or tripling the nerve signal. Sodium ions had no effect. It was specifically the citrate boosting the signal. They concluded that cellular concentrations in real prey are high enough for this enhancement to happen naturally during feeding. In other words, citrate acts as a natural taste amplifier for the amino acids bass love most. Here are 3 practical takeaways we can all use. 1. Use crawfish or shad-based scents rich in arginine and lysine. 2. Consider citrus-based or amino acid-enhanced dips for soft plastics. And 3. In pressured lakes especially, this subtle boost can turn neutral lures into must-eat ones. We all know the adult system, but what about young bass? The brand new 2025 Loose study shows how taste develops from the very beginning. Taste bud development in largemouth bass, from fry to adult. The 2025 study by H. Liu and colleagues tracked taste bud development in largemouth bass from hatchling through 60 days. Taste buds first appearing 5 to 7 days post-hatching as small onion-shaped structures. By 15 days, 2 distinct types emerge: type 1 support cells and type 2 receptor cells. By 60 days, the buds are larger and fully mature. Gene expression for taste receptors changes gradually as they mature. Tune in young bass to detect prey amino acids more efficiently as they age and grow larger. My pond-to-lake journey taught me this over literal decades. Early, I'd ignore scent entirely. Once I started matching natural amino acid profiles with dips and impregnated plastics, my catch rates climbed steadily, especially on pressured fish. A desire for more bites and bigger fish. It explodes when you give bass the exact chemical signature they evolved to love. More committed strikes, fewer spits, and loading the boat on even the busiest bodies of water. Now we have the science. Let's turn it into a simple system you can use every trip. Practical taste strategy and pitfalls to avoid. Build a taste-focused system. 1. Always carry amino acid-rich scents: crawfish, shad, garlic. 2. Dip or impregnate soft plastics in trailers. 3. Prioritize lures with natural prey profiles in pressured or clear water. Here's some common pitfalls. 1. Relying only on scent for location but ignoring taste for retention. Bass strike, then spit. 2. Using artificial sweet or fruity scents that bass reject. And 3. Over-scenting in cold water when taste sensitivity drops. In 2026, public lakes are getting hammered more than ever. These tweaks will give you the edge, put more fish in the boat, and have fewer lost opportunities. Here's your recap. Bass taste is the final decision maker. One study showed the crusher checkpoint, another proved citrate boosts key amino acids, and a third mapped how it all develops. Use the right chemical signatures and watch your hookup ratios soar. Drop a comment on if you're a scent believer. And if you are, what's your favorite? Subscribe to Green Valley Anglers for more science-backed bass tips. Hit the bell, share it if it sharpened your game. Let's keep catching more. Sincerely appreciate you, tight lines, and I'll catch you on the next one.